Good morning. I have to take the floor in this occasion, but this paper will not be possible without Dr. Miguel Carrero, a researcher from the University of Santiago and a specialist in LiDAR analysis applied to the Neolithic tombs. It was impossible for him to participate here, so I will read the whole text of this presentation. LiDAR and their analysis is not my research work, so I apologize in advance if there is any mistake in my text or in my presentation. If you have any queries in this particular field, you can write to my colleague as well. This line of research has been funded by the Valdez Salas Foundation institution, which has a special interest in these archaeological remains. The aim of this paper is to compare the accuracy of LiDAR for measuring prehistoric tombs, in particular the barrows or megalithic tombs of the Salas Council in Asturias, northwest of Spain. Unfortunately, they are not the terrific tombs of ancient Greece, you will see. So, two cemeteries and around 18 structures are involved in this paper made with information provided by LiDAR. Our starting point is the database from the Sites and Monument record carried out in 1990. Our efforts were focused on the barrows that in this area concern Neolithic and Bronze Age chronologies between the 4300 and the 2500 BC approximately. The prehistoric structures were grouped in 17 cemeteries, gathering together around 77 structures. Our project tries to complete all the updating of the Sites and Monument Records database. That is very old. The last update of the database was to scan all the information and convert to PDF each site record. There is no money or projects for updating the archaeological records at other levels. That would be the only way to know the damaged or destroyed structures or to add GPS locations to the Sites and Monument records. We are doing now this work in Salas in short steps and only for the barrows, because we cannot assume all the inventory from the Paleolithic to the medieval age. Even the Neolithic Bronze Age catalog is an enormous effort. LiDAR analysis was carried out using the free data available through the National Geographical Institute in Spain. After applying the LiDAR analysis to all these spaces, the results were checked with fieldworks with the aim to contrast the accuracy of these results. The final step was to gather all the information and to do the analysis to get some results. But firstly, it's necessary to summarize the main problems that we had to deal with in the research and why LiDAR is so important for the analysis. In Asturias, as it happens in other areas of Iberia, like Galicia, or even in European countries like Poland, we are measuring the structures in the middle of the forest. In some ways, woodland archaeology as well. It should be remembered that almost 30 years have passed from the first fieldworks, and extensive trees plantations were carried out along these decades in our area of study. These plantations required more infrastructure, thus the old tracks and roads were expanded to give a path to the heavy machinery affecting to the archaeological sites. The cemetery of San Juan, for instance, could be an example of what happens when this technique is applied in the Asturian megalithism, because LiDAR in San Juan allows quick identifications of the position of the tumulus. This action seems a simple process, but if we sum the dense vegetation, With other affections to the structure, the identifications of barrows in Asturias is not so simple. That's the case of barrow number 2 of the cemetery, crossed by a small road that divided the structure into 2 parts. The right part was easier to identify, but it was not the case in the left part because only 20 centimeters of the prehistoric barrow remains in its original position. With less damage, although barrow 4 was partially affected by a plantation of trees, but you can see in both photos of San Juan, barrows 1 and 4, the situation of the tombs in the middle of the forest. In most cases, they are covered by dense vegetation. Another group of barrows, considered as Hidalga's cemetery, show us the second problem in the updating works. Some barrows are partially destroyed. At this site, 4 clear barrows were identified in 1990. You are seeing now the original structure numbered as 4 at the top part on the left image. However, only 2 appear currently in the LiDAR. In one case, the barrow only can be seen using LiDAR because in the field it almost disappeared after extensive agricultural levelings of this terrain, as we can see on the slide. The other 2 barrows that were part of the site's monument record database, which include a total of 4, can hardly be recognized now, probably due to a similar process of leveling. You can see both structures very close to the number here. Below, we will see that when LiDAR shows small information about the tumulus and its limits, this situation obviously affects the measures that we take with this tool. They are not so precise. Now let's take a look in detail the methods applied in this particular research of the project. The first step, using the LiDAR for measuring the structures. Second, compare the measures with the data from the Sites and Monuments record. We use the measures from these fieldworks rather than our own measures because in 1990 most part of the barrows are clean of vegetation. For this reason, most of the necessary measures are more accurate than our current measures. In our research now, we always have to deal with barrows that are incomplete, partially destroyed, or totally covered with dense vegetation. Finally, we have to contrast both data to carry out the analysis and obtain some results. For measuring the main axis of the barrow, QGS was used, in particular with the profile tool. The height of the barrow is the result of calculating the difference between the lowest altitude of the barrow and the highest. The image from the resampling filter emphasizes the detail of the terrain and the tumulus, and for this reason it was used for the measuring. In order to obtain the volumes and the areas, it was necessary to apply the same calculates than Spanish archaeologist Aguileta Franco used for their dissertation about the barrows in the landscape of the Baixa Limia in Galicia near Portugal. Following to Aguileta, the total area can be estimated with the formula of multiplying A by B. In other words, after multiplying both main axes, north-south and east-west. This formula is not totally precise because it does not correct the irregularities of the structures. Regarding the volume, the formula that we use is based again in Aguileta, where V is the total volume of the monument, H is the highest altitude of the tumulus, R is the average radius. Due to the irregularities of the diameters perceived in most of the tumulus of Galicia, Egileta uses this formula in order to resolve the problem. Thus, the anomalies between the radius are estimated using an average value between the two radius. Following these steps, the radius will be always half of the larger diameter and the minor diameter, respectively. It's a single way to do the calculations, but the system works in this area. There is now a PhD student working in Galicia in a formula to convert all these steps in an automatic process, but until this moment we have to use our system. After these calculations, a table can be obtained combining the dimensions gathered during the sites and monument records in red with the new measures obtained with LiDAR in black. You are seeing now on the slide information about San Juan. I will not detain you with this general data because it's more interesting to jump to some preliminary conclusions. For example, it's necessary to point out that in San Juan, in one of the barrows, the measure from LiDAR is more precise. In others, like barrow number 5 of La Cobertoria, the figure for the height is more accurate in the sites and monument records, although in this tumulus there are small differences between the different measuring LiDAR and sites and monument record. In barrow 4, both numbers show very similar figures. And finally, the barrow number 6, in which the difference never reaches a meter. Only 20 centimeters indicates that light that could be reliable to do this kind of measuring. At least it's very accurate and it's very comparable with human measures. It's important to remark that the accuracy of the measures can be checked thanks to the information provided by our field notes, as well as using the comparison between the different structures and the most reliable measures of some of them. That's the case, for example, of barrow number 5 in San Juan that was measured with the total station during the excavations. You are seeing now on the slide the same kind of table, but on this occasion with information gathered about the Penausen site. In this case, is with more structures. We have 12 barrows, although the number 8 was destroyed during the construction of a road. In this case, it's crucial to stress that LiDAR obtained more precise and coherent measures for 6 structures of the cemetery, as you can see on the slide. However, in 2 barrows, the information was not so precise. Most of this inaccuracy comes from the information available in the digital terrain model. The borders of the tumulus, in some cases, cannot be clearly identified. In Penausen, this situation happens in 2 prehistoric tombs, number 1 and 2. The topography of this area is very confusing because there is a little elevation in this site and 2 structures are very close between them, making it hard to identify the limits of each tomb, as you can see on the slide now. Moreover, the trench dug during the excavations in 1976 is not helpful either. You can see here very clear, I think. Well, when the barrows were built isolated and with very clear borders, the LiDAR works with more accuracy, as it happens in the barrows 3 to 4 on this group. Finally, as regards the volumes in areas, there are plenty of data provided by LiDAR. In the case of San Juan, the information can be grouped into 3 categories according to the volumes obtained, with La Cobertoria number 5 as the most remarkable structure, as you can see on the slide. thanks to the 3D model made with a drone part. However, Penhausen provides interesting accounts about the volumes and with other three very well-defined types. Based on the results obtained, especially in the types 1 and 3, we can suggest that the volumes of the structures can be connected with the evolution of the cemetery along the time, and perhaps with the linkages between the different people buried there. It's very common in the Asturian cemeteries of this age the presence of main tombs with other secondary burials in the surroundings of the mound. That could be also the case of Penhausen. At least the barrows 1, 3, and 5 show remarkable volumes and serve as a main axis for the cemetery. In the middle of these big structures, two secondary tombs were built. Barrows number 2 in close connection with number 1, and barrow number 4 linked perhaps with the number 5. To sum up, and although further analysis is yet necessary for some areas, we can assure that LiDAR techniques, as our paper has shown, can obtain crucial results when revising our records, at least in this area of the northwest of Spain. 6 groups of measures obtained with LiDAR in Penhausen and 1 in San Juan have proved to be more reliable than the sites coming from the Sites and Monument Records fieldworks in 1990. 3 of the structures measured with LiDAR in San Juan shows remarkable coincidences with the Sites and Monuments records record numbers. LiDAR has been proven as less accurate in monuments where the topography doesn't help, where the tumulus is partially destroyed, or when the borders are not totally clear, as it happens in Penhausen, 3 examples, and San Juan, 2 examples. A final remark that is always necessary: check the information provided by LiDAR with intense fieldworking to minimize the mistakes of the technique. That's all. Thank you for your attention.